Hey there, geometry students. So we're going to take a look at the Opt4 Day 23A study guide. Okay, so our first three questions are about factorials. All of these could be done by hand. They could be done with a calculator or a combination of both. Okay, so recall that a factorial means you're multiplying a number times itself. Or not times itself, but all the numbers underneath it. So like 10 factorial over 6 factorial for this first one would mean 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 2 times 1. All of these are going to cancel. So if you're doing this by hand, you could do 10 times 9 times 8 times 7 to get 5,040. You could also plug it into a calculator. So let's see if it's not too big. So if you do 10 factorial divided by 6 factorial, that one it can handle. That's not too bad. You can plug it in that way. Okay, 8 factorial divided by 3 factorial, if you do it by hand, the way that I would do it is I would do 8 times 7 times 6 times 5 times 4, and then I would stop and write the rest as 3 factorial because they're just going to cancel. And then I would multiply the remaining numbers and you get 6720. 5 factorial times 3 factorial divided by 4 factorial. Now, 5 factorial times 3 factorial is not 15 factorial. You can't do that with factorials. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. You can see that that's not going to be the same as 15 factorial. And then 4 factorial in the denominator is 4 times 3 times 2 times 1. Cancel what you can. Multiply what's left. You get 30. All right, seating arrangements. So when they do something with seating, you should be thinking about something called circular permutations. And we want to find the number of possible table arrangements for each number of officers who are seated around a table. So the formula for circular permutations is n minus 1 factorial. It's not n factorial because we don't care where the first person sits. It's just sort of like the first person can sit anywhere, and then the arrangements kind of happen after that. So if there's 5 officers, we're going to do 5 minus 1 factorial, which is 4 factorial, which is 24. For 8 officers, there are 8 minus 1 factorial, or 7 factorial ways, which is 5,040. For 10 officers, it's going to be 10 minus 1 factorial, which is 9 factorial, which is a large number of 362,880. Again, you could just plug this into a calculator. You can multiply 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, question number 7. Suppose you form 4 letter strings from the letters, and there's a list of letters there. What are the number of permutations as a ratio of factorials? Okay, so a permutation is an ordered thing. So the permutation formula is you have this large number n, which is the what you're choosing from. Okay, it's what you're choosing from. So you have like a list of things. And then R is how many you are arranging. How many of those n things are you arranging? And it has to have an arrangement in order. Okay, and then the formula is n factorial divided by n minus r factorial. So in this case, let's see how many letters we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 letters, and we are choosing 4 of them. So we're going to do 9 factorial over 9 minus 4 factorial, or 9 factorial over 5 factorial. We can probably figure this out pretty easily. 9 times 8 times 7 times 6 times, and then the rest is just going to be 5 factorial. And then the 5 factorial will cancel, and it's just 9 times 8 times 7 times 6, which is 3,024. You can also use a scientific calculator. The Desmos calculator, not all scientific calculators have this, but the Desmos calculator does have a permutation button, and we would do 9, 4 as an ordered pair to get 3,024. Okay, moving on to number 8. A two-way frequency table shows what male and female students eat for breakfast. What is the relative frequency of males who there's a missing word here, who eat eggs or cereal? Okay, so how do we get this percentage? So males that eat eggs or cereal. That's 45 and 79 for eggs and cereal respectively out of 342. So because it says or, you can think of it like, okay, we can do it a couple of ways. We could do 45 out of 342 plus 79 out of 342. Or, because it's a common denominator, you can just add 45 plus 79 and then divide it by 342. So 45 plus 79, oops. Oops, I forgot the 4. Let me divide that again. Okay, and you get this 36.3, although it says 36.257, but it says round to the nearest 1/10%. Okay, then there's a second part. If you randomly select one of the students, what is the probability that that student is a female who eats oatmeal? So we got to look here and find female who eats oatmeal. Female column is here, oatmeal is here, that's 65. So that's going to be 65 out of 342. No adding necessary here. And it gives you 19%. Okay, number 9. Jennifer gets on base 3/4 of the time she bats in a softball game. What is the probability that she will get on base 4 times out of her next 8 times at bat? Round to the nearest 1/10%. So this one is an expected value problem. Okay, so for more information on these types of problems, look up expected value. I am wrong. It's not expected value. I'm thinking of the next section. Okay, wrong. Ignore what I just said there. This is a independent trials problem. My brain just mixed them up, sorry. Independent trials. Okay, so pretty much what we have to do is we have to do a combination where n is the number of trials and r is like the number of, like, whatever they're asking about. So if you look right here, it says, what is the probability that she will get on base 4 times? So number of successes, I guess you would say, of those trials. Okay, then you multiply that times the probability of, let's say, B for getting on base. That's the event we're trying to get. That's the success, to the power of R times, which is how many times we want that to happen, times the probability of the opposite of that, which is not getting on base, to the rest of the times, and you just subtract n minus r to see how many times are left. So the probability she's going to get on base is this 3/4. So the probability of not getting on base is 1/4. It's the rest of the time. So 3 out of 4 times she's on base, 1 out of 4 times she's not. Okay, so my trials is 8 times at bat, that's N. 4 times we want to get on base, that's R for this formula. So I'm going to do combination of 8 and 4 times this probability 3/4 to the 4th power, because that's how many times we want to get on base, times the probability she's not going to get on base, which is 1 out of 4. Now, since there's 8 trials, and she got on base 4 times, we wanted to get on base 4 times. That means the other 4 times is going to be not on base. So this is basically subtracting 4 from 8 to get 4. Okay, we can just plug this all into a calculator and go from there. Because, once again, I can just use this to find that. So, but I'll tell you the formula in case you need to do it by hand. So the combination formula, I'll write it up here, is like the permutation formula, except it's n factorial minus n minus r factorial. But the difference is there's an r factorial in the denominator. So you can do it by hand. I'm just going to use a calculator. Okay, so that I can see that it is 70. And now I'm going to multiply times 3/4 to the power 4. I'm just doing this all by hand, okay? Or by calculator, not by hand. 1/4 to the power of 4. Okay, so this is a probability. It should be a number less than 1. If you don't get a number less than 1, something happened. But I can see that it's about 8.6%, 8.7% if I round it. Let's see, how do they want us to round it? Yes, 8.7 to the 10th of a percent. Okay, so it was 0.086, what was the number after? 5. So you move the decimal to the right twice and round it to the nearest 10th of a percent, you get 8.7%. Okay, number 10. Players at a carnival game win a prize if they are able to throw a dart and hit any one of 5 targets. The diameter of each target is 6 inches. Okay, so this one can be a little tricky because they're throwing different units at us. We've got feet here and inches here. You need to be in the same units the entire time. So I'm going to choose to change the feet into inches, but you could also just choose to change the inches into feet. But if I go that way, I'm going to end up with fractions. So I'm going to multiply 1.5 feet by 12 inches, or 12 to get inches. And then this is also going to be by 12. So this is 48 inches and 18 inches. Okay. So this is geometric probability, which has to do with area. The area of the darts compared to the area of the whole thing. So we need to do the area of the darts, which are the circles, and divide it by the area of the whole thing, which is a rectangle. Okay, so the diameter of each target is 6 inches, which means the radius is 3 inches. Let me draw one a little bigger so we can see it. 3 inches. So we're going to find the area of a circle. That's pi r squared, but we're going to have 5 of them. So this is the area, this is going to be my numerator. So 5 times pi times 3 squared. Or that's 9. 9 times 5 is 45 pi. Okay, so there's my numerator. I'll plug it into a calculator in a second. And then the area of the rectangle is just length times width, which is 48 times 18. Which is 864. And now I'm going to put this into a calculator to divide it, and that's going to give me a percentage. It's basically what percentage of this dartboard are the circles. Okay, so fraction, 45 pi, 864. Move the decimal, that's 16.4%. And there it is. Okay, I'm going to do the rest of the this in a second video. So if you need questions 11 through the end, watch the second video.